Hello student, this is Pawan Kumar, Assistant Professor in Department of Civil Engineering, Thandai Periyar Government Institute of Technology, Vellore. Now we are going to discuss about a matrix method of analysis of structure. It is one of the method of analysis of indeterminate structure. Previously we have been discussed about a strain energy method, moment distribution method, slope deflection method, but these are the method will not be conveniently used for the analysis of present day multi-story building. Why it is? Because a multi-story building having n numbers of floors, so because of that the degree of static and kinematic indeterminacy of the structure will be higher. So basically these are the methods as solved by manually. So if the number of unknowns is more means, so it is very tedious to solve the structure by these methods, either strain energy method, slope deflection, moment distribution method. So we have a need for the analysis of multi-story building, and also the evolution of computer have given rise to new method called a matrix method. Basically, so there are two method of matrix method. So one is flexibility matrix method. So another one is stiffness matrix method. So flexibility matrix method, it is evolved from the systemic development of a consistent deformation method in the matrix form has lead to flexibility matrix method. Stiffness matrix method, it is evolved from the systemic development of slope deflection method in the matrix form has given rise to stiffness matrix method. So flexibility matrix method, it is also called as a force method, or it is also called a compatibility method. Why it is called compatibility method? So we have to use a compatibility equation to analyze the structure, to determine the unknown forces. So in the stiffness matrix method, it is also called as a displacement method or equilibrium method. So what is called equilibrium method? So with the help of equilibrium equation, we can analyze the structure. That means we can find out the joint displacements. Okay, so therefore it is called equilibrium methods. Now move on to different approaches to matrix method. There are two approaches to the solution of matrix method. One is system approach, another one is element approach. System approach, it is also called as direct or informal approach. In this approach, the flexibility and stiffness matrices may be developed by considering entire structure and determining either displacement due to unit forces or forces due to unit displacement. So this method will be used in your structural analysis topic. Then element approach, it is also called as a transformation matrix approach or formal approach. In this approach, matrices are synthesized from flexibility or stiffness of the elements or members by means of transformation matrices. This method is more appropriate for computer application. Then let's see the basic properties of matrix. So these are the things you are studying in your mathematics. So what is meant by matrix? A matrix is an array of elements which are sequentially arranged in rows and column. If a matrix is A, then it means m rows and n columns. Then second one, so what is meant by square matrix? A matrix which has equal number of rows and column is called as square matrix. So 2 by 2 matrix or 3 by 3 matrix, 4 by 4 matrix, these are the square matrix. The number of rows and number of columns are equal. So generally the flexibility and stiffness matrices will always a square matrix. Then third one, unit matrix. So unit matrix is that which has unit element along the diagonal. All other elements have zero values. Then fourth one, diagonal matrix. A diagonal matrix is that which has all other members zero other than diagonal members. Then fifth one, the magnitude of the matrix represented by its determinant or determinate. Then sixth one, a determinant will have zero value if any two rows or columns are identical. The sign of determinant will change if any two rows or columns are interchanged. Then eighth one, a singular matrix is the one when the determinant of it is 0. So generally the flexibility and stiffness matrix is a non-singular matrix. Non-singular matrix means the determinant of the matrix will not be 0. It's not equal to 0. If it is equal to 0 means it is called as a singular matrix. So in the flexibility and stiffness matrix is a non-singular matrix. The ninth one, a new matrix obtained by interchanging rows and columns of the original matrix is called transpose matrix. Tenth one, a square matrix Aij is said to be symmetric when A is equal to A transpose. That is, the original matrix and the transpose matrix have same, means that is called as a square matrix. Then inverse of matrix A. So matrix inverse only exists for a non-singular matrix. So I already said stiffness and flexibility matrix are non-singular. So therefore inverse of that flexibility and stiffness matrix will exist. So inverse of flexibility matrix will give stiffness matrix. Inverse of stiffness matrix will give flexibility matrix. So A inverse is equal to 1 by modulus of A into adjoint A. So adjoint A matrix obtained by transpose of a cofactor of matrix A. Thank you.